Okay. So the Future Materials Bank gathers sustainable materials which have been developed, discovered, or rediscovered by different practitioners all around the world. And it's aimed to foster and to support a sustainable transition in arts and design practices. The aim is to invite to embrace more mindful and responsible approaches to our material choices, to the material choices we take in our daily practices. So how we do this, how the Future Materials Bank does it, it's through exploring and suggesting possible alternatives to fossil-based materials or toxic materials which are common in art and design practices. This is on one level. On another level, it works also very much on an inspirational side in order to really invite to think about to think critically and to embrace a reflective mode when we think about materials and when we make decisions about materials, in order to think about the meanings and the implications this material might have on the humans and on the environment. So there are like these two different levels, which are mirrored also by the different composition of materials on the Future Materials Bank, because if you had the time to spend some time on the platform, you might have seen some materials which have really like a DIY, do-it-yourself approach. So they really have recipes, and you can really kind of reproduce them or make them in different contexts. Other contexts, other materials or other projects are more complex. They entail specific knowledges, specific facilities, specific tools. But both of these categories, let's say both of these kind of materials, fulfills a common goal, which is the one of, I think at least, and Plön, who's also working on the bank here, might just share her opinion later with us. But they really are aiming to unlock material imagination. So how can we think about alternatives to materials that we are using which are toxic for different species, for the environment, but also for us humans? And also, how can we think about materials and materials alternative as companion which can come with us or can help us in the transition beyond the fossil modernity we're embedded in, right? So yeah, this is a bit about the Future Materials Bank, and the Future Materials Encounters is a program which actually indeed wants to activate all the knowledge and all the community also of makers, which is part of the Future Materials Bank. And so basically we are going to invite in this program a maker every 2 months who's going to walk us through or to explore with us the language of the materials she, they, he have developed in the practices, in his, her, or their practices. So when I'm talking about language of materials, it's because I'm really thinking about the physical, sensorial, and aesthetic properties of materials, which are also very important in our practices, I think, but also not only to this, but also to the cultural history, histories and fictional stories, political meanings, and philosophical understanding that are embedded in a material. So in order to really try to look at all these different aspects, points of view and perspectives, the object that we are going to explore in these appointments, in these encounters, are becoming boundary objects. So objects which can really mobilize all these different perspectives, and also like hopefully opening up new imaginaries about the way we relate with materials. Yeah, so one of the, this is also why you will discover, you will see, for each of these encounters, we're going to invite also another voice to join the dialogue with the maker who contributed to the Future Materials Bank. Today we have Rosie, textile designer, and Chris, who's a microbiologist, but hopefully like in the next encounters, depending on the material and depending on the possibilities, we might have anthropologists, historians, physicians, political economists, and storytellers, and who knows who else. So this is one. The other aspects I would like actually to explore with you with this program, and hopefully indeed you will help me with, is actually about the sensorial approaches to like a sensorial way to understand the world and the reality around us. So for instance, like especially thinking about materials, the question here that I'm posing you and that I would like to explore with this program is which kind of realities, which kind of word-making practices unfold when we touch, when we taste, when we smell, when we hear or listen to a material, even. And especially in this context, touch is a particularly inspiring approach because it entails an intrinsic reflexivity, or better, reciprocality, a reciprocal quality. When we touch something, we are necessarily touched in return. So in this sense, the material is also talking to us, communicating with us in a way. So I'm just like, this is a question, an open question that hopefully we will have the time in the upcoming months to explore together. But it's really about thinking about possibilities to understand the reality around us, the material configuration and all the meanings they entail, which go beyond the visual, which entails the visual, but go beyond it. Okay, so just a few practical notes before leaving the stage. So we will have an encounter every 2 months. I'd like to think this program as collaborative, as collective, so I'm very open to receive suggestions and proposals from you about materials that you might have seen or encountered in the Future Materials Bank and that you're interested to explore more. These are materials that you might be interested to use or to explore in the framework of your practice, or even just materials you are curious of, that you have been intrigued by, and you would like to hear more, or just to engage in a conversation about them, because you find them inspiring. So I already received some suggestions about materials, but I'm very welcoming more. So feel free just to drop me a line, or to come to my office to ask for it. So with not further delay, I leave the stage to Rosie and to Chris. And I know you're going to introduce yourself by yourself, okay, so yeah. I'll just leave it to you.
Hi everyone, so I'm Rosie and I'm a textile scientist at Ghent University, and I collaborate with Chris, who's also on the call. He's a microbiologist and skin expert, and together we collaborate to develop biomaterials together for the fashion and textile industry. And actually my background is in fashion design, and I worked in research and development for sportswear brands, where really the goal was to develop materials for speed, comfort and durability. And so it was about what can we add to these textiles to provide function for the athlete. And really my interest in skin and the textiles interaction led me to do a master's on material futures at Central St Martin's. And this course is sits between the intersection between craft science and technology. And I was looking about what is abundant on our body, or how can we use our own biology to add function to textiles in a more natural way. And that's when I came across the research of Chris, who develops bacteria transplantation. And so I'm going to talk a bit about, give some context to the project and how bacteria transplantation has led to a project on fashion and textiles. So there's hundreds of thousands of bacteria on the body, and actually only about half our cells on our body contain the human genome. And these human cells interact with viral, fungal and bacterial cells. And the understanding that this symbiotic nature between our own cells and other bacterial cells, I think changes the way we consider our physical identity. And before this talk, Julia sent me an essay by Scott F. Gilbert, and I thought that this essay really framed what I wanted to talk about here today. And there's a quote, I don't know if you can read a bit. It's, in theory, the organism in an individual whose component part cooperates for the betterment of the whole, but the parts that cooperate can be other organisms living with it. So this artwork on the right is by artist and researcher Sonia Boumel, and she really is questioning whether the environment ends and the body starts, or vice versa. And she basically, on a human-sized petri dish, she grew her own skin microbiota, and I thought visualizing this very invisible layer that's on our skin and these cells that are living in symbiosis with us. So, so the skin microbiome, it is comprised of billions of cells. And this interaction between biome and skin is responsible for releasing toxins from the body and protecting us from chemicals and other pathogenic bacteria. So it works as a kind of permeable membrane, keeping the inside in and the outside out. And so this relationship between host and microbiome is typically beneficial, but the symbiotic nature can change if there's a disbalance in the ecosystem, which can lead to a dysbiosis. So through our research, we look at how the composition on the skin is closely connected to our health, our overall health. And so the living ecosystem on our skin relies on our bacteria to function, and has changed the way we understand and target disease. So the human skin is divided into moist, dry, and sebaceous sites, and each of these sites have its own microorganism ecosystem, but similar at species level. So the bacterial differences play a role in the microbial, fungal, and viral stability on the human skin, and has provided insights into site-specific skin conditions. So the graph on the right, you can see that the composition, the bacterial composition differs vastly in the axillary microbiome or the underarm microbiome compared to the foot microbiome or the scalp microbiome. So how you might target these different areas of the body would differ entirely. And so the skin microbiome has faced many challenges, mainly to do with society's obsession with cleanliness and hygiene practices, and urban living has meant that it's more difficult for these microbes to survive. And this has meant that there's an increase in skin sensitivity and skin disease in the Western world. And the fashion industry often develop, or the fashion and sportswear industry develop materials that fabrics and materials that have a functional element to it, which often use chemicals that are known to be toxic to the body. So waterproof finishes use fluorocarbons, which are highly toxic for the body and the environment. And antibacterial finishes use silver and zinc, which would kill all of the bacteria on your skin, and this leaves it more susceptible to an overgrowth of a more harmful bacteria and multi-strain resistance. So what we wanted to do was see what has been on our body for hundreds of thousands of years, and how we can work with that to add function to performance clothing. We developed probiotic clothing, which means encapsulating healthy, beneficial bacteria into textiles to change your skin microbiome for the better. So we encapsulated the bacteria in areas that you're most likely to sweat, because the bacteria need moisture to activate, and then once activated, they'll start to colonize on the skin and become the more dominant strains. And this change in microbiome is associated with reducing your body odor, like Chris said, encouraging cell renewal, and is helpful for the skin's immune system. And so this idea is to replace antibacterial finishes and chemicals on clothing. And then also it may, because of the reduce of body odor, it may mean you don't need to wash your clothes so frequently, which has an environmental impact also. And so, of course, working with bacteria has many challenges, and so there's very specific criteria in order to how to encapsulate these microbes into textiles for clothing. So the bacteria has to be skin commensal, something that is considered healthy or probiotic and prebiotic on the skin, not associated with malodor or skin disease. And the application method is important because we're using something that is already on the skin, that's healthy, that's natural. We don't want to then apply it with a toxic binder, for example. Fixing at a low heat, because the bacteria we're using is sensitive to heat and also water. We don't want to activate the bacteria too early before it's applied to textiles. And then also durable. And then, as Chris mentioned earlier, the textiles has an influence on the microbiome of your skin and your clothing. So we want something that, for example, polyester generally pathogenic bacteria tend to grow on polyester or synthetic fibers. and it needs to be suitable to wear next to your skin, also moisture wicking and pH neutral. So a lot of what we do is lab testing and wear testing. So in order to test it in the lab, this means we have to find out, is the bacteria present in the textiles? And so if we're leaving the encapsulated bacteria at room temperature, is it decreasing over time? Is it wash durable? And is it sensitive to heat? So these are all different elements that we think about when applying bacteria to textiles. And then we also conducted a wear testing trial where we encapsulated these healthy strains into one side of a t-shirt, and we got participants to wear this t-shirt over 2 days, the same t-shirt. They did sports in this t-shirt, so they vigorous exercise to make them sweat in the garment. And then we asked them to compare the left and the right side of the garment using a questionnaire, and then they gave the t-shirts back to us, and we had a internal odor panel to test if the left smelled better than the right, which it did. And then it went off to, we extracted the textile microbiome and sent it off for sequencing to see if we expected these microbes as well. So because probiotic clothing is generally a new research field, we had to sort of develop the experiment design ourselves. So we came up with a criteria or a method of how to extract the bacteria from textiles, which we do by cutting a 1x1 square of the fabric, putting it into an Eppendorf with physiological water and glass beads, and then putting it in the centrifuge, and then diluting and plating it onto Petri dishes. And this is where we can establish how many microbes are on the textile. So I have some lab work in progress. On the right is a diamond knife. This is when we're trying to look at the bacteria under the microscope to see if the sort of shell that we've encased it in to protect it is present. So this is done by setting the bacteria in a polymer, and then it's cut at a very, very fine layer. You can't really see it you can't really see it, and then it falls into this pool of water which is above the blue. There's a pool of water there, but then to fish out the bacteria polymer, the technician uses her own eyelash on the end of the stick because it's so small. We grow bacteria on Petri dishes, and this is how we count them. This is a bucket of bacteria before it's processed, before adding to textiles, and then DNA extraction is a key part of what we do also. Oh yeah, that's the diamond knife moving. And then durability of the probiotic textiles is very important. I think it's one of the main things that people ask me. If I put it in the washing machine, are the bacteria going to come out? So we look at how can we make these bacteria more durable, and we use certain materials to encase the bacteria through spray drying, microencapsulation. And also we analyze the heat stability of the bacteria, because the textile industry is and they have certain ways of developing textiles, and usually most processes you need a fixing temperature of around 130 to 150 degrees, which is a challenge for us, but we're trying to develop how we can develop a more heat-stable bacteria. And then also essential oils. We wanted to see if we could add other therapeutic ingredients to textiles if it had a beneficial effect on the skin. So we've been working together for 3 years now, and the development of the textiles has come a long way. On the right, this is where I encapsulated the bacteria through a printed technique, and although this technique worked, it was a very hydrophobic technique, and we wanted to create something that was more invisible, and you couldn't really see the finish on the textiles, which we've achieved in the sample on the right hand side. I also, to exhibit or to communicate this work, I wanted people to know that there was something inside the garment, because I applied the bacteria to the inside of the garment because I wanted it to be in contact with the skin. So I put the bacteria in areas that you're most likely to sweat, so down the back, between your breasts, under the armpit, and then used a light box to highlight where these bacteria had been placed on the garment to show the garment was alive somehow. And I have a video here. So other areas that we're working on now, future research, we're exploring multiple strains of bacteria. So this garment was to target body odor, but for example, if you were to develop socks, or if you were to develop a mouth mask or a hat, you would be targeting a different microbiome and therefore a different bacteria. Fabric composition is an important area to establish the bacteria. So does the bacteria grow better on a cotton or polyester, for example? Partners and collaborations is an important part, and working with fabric finishing companies. And wear testing trials, we want to continue developing wear testing trials with 50 participants plus to see if, because really it's down to if people are noticing a difference in their skin microbiome or body odor. It's important. So new research, I'm looking at probiotic underwear and encapsulating a strain that is most dominant on the vaginal microbiome, which has an anti-inflammatory effect, encourages cell renewal, and is disease prevention for female intimate health because it has an anti-pathogenic effect. And this application could be for females who are prone to yeast infection, menopausal women, or pregnant women. And then also the scalp and facial microbiome. Often dandruff and atopic dermatitis are the result of an imbalance in the microbiome ecosystem, so which is due to an increase of malassezia, which is a fungus. And so we're looking at how we can add certain actives to textiles to potentially alter or change this growth on the face or scalp.
Last one. I just wonder what are the garments or the samples you brought. If you can just, I don't know if we can see it from the camera.
Something that's already in the future material.
Yeah.
Okay, and this is actually something I went to the lab last week and I took a sample of something that this is something that's just been in a plastic bag in the cupboard in the lab. So this is the first time it's been out.
Can you smell? Or what do you smell if you can smell something?
I don't know, because this is like what I was saying to you. Sometimes if we don't know if it's if there's bacteria present, we just smell it, and then we know.
So, I don't know if you can hear me, but can you elaborate on that? So on this, it's very interesting, like this fact that you smell the textile in order to understand whether the bacteria are there or not.
Yeah, because I think, like Chris said earlier, it's grown on a medium, so it's not the bacteria that smell; it's actually the medium that has a slight smell. So we know that, because every time we develop samples, we always create blanks because we need to compare it with what has not been applied and what has. So then you can usually tell the difference between the two like this. And then this is just an example of how I if I want to know how much bacteria is in this sample, I would cut 1 by 1 centimeter square. Usually I put it in physiological water, which has no sterile water, and then I add glass beads, and then I would put them in it's not the centrifuge, it's called the, it's a good name. I feel like all the lab equipment have really good names, but it's called like, anyway, it shakes around a lot, and you put these in.
Bead meter. The bead meter.
Oh, I thought it's better than that, I thought. Anyway, yeah. The powerlizer, yeah, that's it. Okay. We'll put it in the powerlizer, and then it shakes it around, and then yeah, and then I dilute it, because of course if I put it on a petri dish straight away, there's going to be so many bacteria that you can't even, it's just not countable. So then you dilute it to a point where you can count the colonies on the plate, and then you then you calculate how many is in the textiles.
Okay.
Yeah.
And the other one, like the pale white, the offset white.
This is a silk seaweed composite. This isn't got bacteria on, but this is just like new developments, because I'm also develop therapeutic fabrics, because the bacteria fabric developments are ongoing, but I wanted to develop fabrics that can have a antioxidant or anti-inflammatory impact on the skin. So this is a silk seaweed composite, and the seaweed gives it these properties.
Oh, okay.
And then this is one of my original samples. It's got bacteria in areas in the inside of the garment where you're most likely to be sweating. But this is like an early sample, and this is kind of more way. I mean, the fabric is quite heavy, but where it's blue is where the bacteria has been applied, and I mean you can't feel anything. So
Okay.
yeah.
If you want, you can touch them. You can come here later and touch them. Okay, so I don't know if there are any other questions. Just the camera. Otherwise, yeah, we can just we can close it here.